Hello, everyone, and welcome to this afternoon's remote schooling pilot webinar, LabsLand webinar today. So we're very happy to have you here. And so to start this webinar with, I will just give a very brief 5-minute intro presenting the IMPACT EdTech program and introducing this webinar. So first, few words on what is IMPACT EdTech. We are a consortium of 3 partners with complementary expertise, and IMPACT is a European incubator accelerator for startup and SMEs. So the 3 partners are European SchoolNet. It is a network of 32 European ministries of education, and we team up with ISDI, a worldwide leader in digital education, as well as Funding Box, and EU experts in funding opportunities and knowledge. So currently at IMPACT, we are supporting 43 European startups, digital education innovators via 2 open calls. So first open call that is still ongoing, and open call as known as remote schooling open call, and LabsLand is a startup that is part of this second open call. And just for your information, we also have a third open call that has just opened. So we're taking on applications here. So should you be interested to submit your application or to know more, I invite you to visit the IMPACT EdTech website. Our goals are IMPACT. Well, we do have many of them, and amongst them, we seek to enhance learning experiences, to foster personalized and inclusive educational models, as well as opening a whole new area of human-centered digital education. As I was mentioning, this remote schooling open call targets EdTech solutions that address the challenges faced by schools, by teachers, by learners during the COVID-19 crisis. And we promote these innovative solutions such as LabsLand because we believed that they address and bring answers to these 2 different aspects of remote teaching and learning. In this open call were 147 startups eligible, and we only selected 10 that are the most promising solutions to address these challenges, and LabsLand amongst one of them. These startups were fast-tracked into a 5-month acceleration program, and today's webinar will highlight the great results and insights from the LabsLand acceleration program, with a focus also on the pilot of their solution. So very much looking forward to hearing more. What makes us unique at IMPACT EdTech? So for startups, they get equity-free financial support, but also thorough business and educational mentoring, as well as the opportunity to pilot their solution in a real educational setting with students and their teacher. As for teachers and schools themselves, thanks to IMPACT EdTech, they get access to the most innovative educational technologies, and they get to support these startups, these innovators, in improving their solution, because the feedback of the teachers and the students is much needed, much appreciated for the startup to achieve EdTech excellency and improve their solution overall. That is all for me. Thank you for bearing with me for this very brief intro. Should you wish to know more about IMPACT EdTech, I invite you to visit our website or to write to me directly. My address is shown on the screen. I will now leave the floor to Tanya. She will be ensuring moderation during this webinar, and I'm here also today with my colleague Sophia. She's in the background, and she's ensuring the technicals and that everything runs smoothly. So we have a very complete team today. Thank you.
Thank you very much, Roman, for the presentation of the project today. And thank you very much to everyone that is already here. I see people attending. So I hope you all grab your coffee for today, because we're starting with the LabsLand webinar. We have with us Luis, Daniel, and Ivan. Luis is co-founder of LabsLand. Daniel is going to talk today on behalf of the pilot teachers, and Ivan has been the educational mentor of LabsLand. And LabsLand, it's difficult to pronounce that, Luis. I don't know why you chose that name. So LabsLand is an educational technology company that is focused on recreating remote laboratories, and it's focused on STEAM and STEM subjects. So Luis, the floor is yours to explain us a bit about these 5 months and the point of view of the startup of the piloting phase. And just remind you that you have around 10 minutes. But I think you're going to make it in 5, and then Daniel will have 15. So the floor is yours, Luis, and whenever you want, if you have a presentation to share, feel free.
Okay, thank you very much. Let me share my screen. Perfect, so you should be seeing my presentation now, is that right?
Yes, we see it. Perfect.
Okay, perfect. Okay, well, so the first thing that I wanted to say is, well, thank you to the people that are from IMPACT EdTech, because you are doing a great job managing this project. And well, some of you might know us already, some of you might not, but in LabsLand, what we do is to provide access to real educational laboratories and equipment, but online. That's basically what we do. Okay, as well as you already mentioned, but I'll give some more details very fast. First, I will simply try to be very brief and tell you a little bit about LabsLand and how the laboratories work. But then we will move on to Daniel Aguirre, who will show you some demonstration of what LabsLand is much better than I. And he was one of our pilot teachers. He did a great job with his students, and he has dedicated a lot of effort to this pilot. So I'm sure that his experience using it will be very, very interesting for all of us. And finally, we will move on to Ivan, who has been our educational mentor. He has provided us with a lot of good advice during this period, and he will discuss the results themselves, the next steps, and those things. So in LabsLand, one of our core beliefs is that a society with better trained students, a society with students with a more scientific and technical education tends to result in a better society. The problem is that to provide high quality technical education and scientific education, students need to do real practices, and they need to do experiment, and they need to use equipment. What kind of equipment? Well, the equipment that are normally used by schools today, such as equipment for physics, for robotics, for biology. The thing is, however, that doing those practices is actually quite hard. It's hard for the schools, for example, because it has a lot of costs. For example, they need to purchase the equipment. They need to ensure that the laboratories are working properly. They need to have some people maintaining those laboratories, monitoring the laboratories while they are being used for safety, things like those. And for the teachers themselves, it's also quite hard because the teachers need to take all the students to the lab. They need to prepare the session and dedicate a lot of time to it. They need to ensure that the equipment that they are going to use is working before they actually start the class. There are a lot of complexities involved and a lot of things that require a lot of time from them. Also, very related with this is that we think that to provide high quality technical and scientific education, memorization is normally not enough. The students need to actually experiment, they need to do exercises, they need to take an active role in their learning. So to try to answer this problem, to try to provide a solution or a partial solution for all this, what we do is to provide access to those laboratories, to those equipments, but online, in a more convenient, in a faster way. So for example, you can see that students that you can see on the right, for example, are controlling or can control a laboratory such as robotics, but using simply a desktop or a different device, of course. Here I show you one example of such a laboratory. It's important to remark that actually we have many different types of laboratory. In fact, one of the complications of the pilot is that we have many laboratories for different fields, so the experience can actually vary quite widely depending on the laboratory that you use. So anyway, this is, for example, a laboratory for robotics. And as you can see, it's real hardware. It's not a simulation. There are simulators for robotics, but in our case, it's completely real. And the thing is that it can be controlled through a web interface that you see on the right. So as you can see, you have controls, you have a camera, and you can basically do the same that you could do in front of a real robot, other than touching the robot, of course. One important thing to remark about all this is that we don't develop the labs on our own. Instead, we always develop the labs and we collaborate with, to create those labs with universities. That's why we always try to deploy every lab in at least, in several universities. So for example, the lab that I showed you, the robotics lab, is not only in our offices, but also it's in universities in South Africa, in Costa Rica, in Colombia. You can see here some of the different copies because we have more. And the point of this is that way we can ensure that if you have a class full of students that want to be using the lab at the same time, you can do that. There is no problem. Or if the laboratory at a particular university breaks, because real hardware breaks from time to time, it's no problem either, because there will tend to be a laboratory that works somewhere else in the world and the student won't even notice. So, because we have those two goals, one, to provide a lot of different experiments for different fields, and two, to ensure that each experiment is deployed in several universities around the world, we collaborate with quite a few universities, as you can see. At the moment, we are collaborating with 27 universities in 15 different countries. The labs themselves, many of them, or most of them, in fact, are targeted towards schools, but actually most of them are also hosted in universities. I'm not going to get into detail on how the labs themselves are used, because Daniel will show you later an example and he will do a better job than I. But I will provide you with an overview of some of the labs that I wanted to highlight in a couple of fields. So, for example, for technology, which is a field that we have quite a few laboratories for, we have, for example, the Arduino Robotics Laboratory, which lets students control a robot, learn programming, learn a lot of things. You can see it on the left. Another example is the Arduino Boards Laboratory that you can see on the upper right of the screen. In this case, it resembles one of the typical Arduino kits that students use to get introduced to Arduino. In this case, also, you don't only have access to the Arduino itself, but you have access to peripherals such as motors, displays, LEDs, and other peripherals like those. And finally, in the technology field, I wanted to highlight the electronics laboratory. The electronics laboratory lets a student build circuits. So he can, or they can, or she can take components such as a resistor or a capacitor, arrange it in a circuit, and then use instruments such as multimeters or even more complicated instruments such as oscilloscopes and take measurements on that circuit. That's a very useful laboratory. Okay, as I was mentioning, we also have other fields. So for example, for physics, we also have quite a wide set of labs. In this case, the labs are normally used in certain sessions throughout a physics year. For example, a physics teacher might want to have 4 practical sessions in his course, so he can use those laboratories to provide access, to conduct those practical sessions in a convenient way. And we have more fields. We are getting started into chemistry, into biology, but at the moment we are strongest in physics and in technology. So I highlighted those. If you want to take a look at other labs, at what other labs we have, or if you just want to take a look at our website, you are of course invited to do so. And also, I wanted to invite you for being here in this webinar by IMPACT EdTech, to join, if you want, a free pilot. So if your school would also be interested in this kind of technology, in this kind of solution for their students, if you send us an email, we will be very happy to set you up with a space and discuss this pilot, this free pilot with you. So with this invitation, I thank you all very much for listening, and of course, I leave the ground for Daniel. Thank you.
Thank you very much, Luis, for the presentation. It was really interesting to see that the labs are not only online, but are also on site in different universities. So that was something that interests me a lot. And well, you heard Luis, they're not only in physics now, they're also starting in chemistry. And though physics and technology are their main fields, and you already heard him, I was saying like they're welcoming you to text them and send them your email, and they will allow you to test their solution pilot for free. So please, if any teacher in the chat is interested, just text Luis after the webinar. Thank you very much for that presentation, Luis. Now I'm going to give the floor to Daniel. Daniel, I'm going to kindly ask you to try to keep it on time, because Luis, those weren't 5 minutes. So just to make sure we have enough time at the end of the session for a Q&A, for all of us to have a chat. Okay? Thank you very much, Daniel. The floor is yours.
Okay, thank you, Tanya. I'm going to share my screen again. Can you see again?
Yes, perfect. Yeah, we can see the LabsLand homepage.
And now PowerPoint. Well, first of all, thank you to the organizer, and thank you to LabsLand also for giving me the opportunity to present my experience. My name is Daniel Aguirre. I'm trying to. Oh. I'm having some problem with the presentation. Okay. I am a pilot teacher. As you know, I am a physics and technology teacher in Spain, on the south of Spain, and I am also a scientist ambassador. To start my presentation, I have a question for every one of you. If we ask to our students about their favorite subject, maybe most of the people who is attending here is science or STEM teacher, but of course, unfortunately, our subjects are not the favorite for our students. They prefer physical education, not physics. Then we need to change our way to give the lessons, of course, because usually most of the time our students.
Daniel, sorry to interrupt, but I think that we should be seeing your presentation.
Yes.
We are actually seeing only your browser.
Yeah, we only see LabsLand website.
Okay.
I think you might have chosen that window rather than the full screen.
Okay, I try to set differently. I'm opening a lot of windows, and now.
Yeah, it happens.
I will start again. The presentation. Now, can you see PowerPoint at this moment?
Yes.
Yes, now we can. I can see experience with LabsLand in the classroom.
Okay.
Okay, yeah. That's great. You can make it bigger if you want.
I understand. Yes. No, it's not possible to make bigger because my problem is with my PowerPoint doesn't allow it, I think.
It's okay. We can see it. Don't worry. And if anyone has any questions after for Daniel, just write them in the chat. We will talk about them in the Q&A. So go on, Daniel.
Thank you. Then, like Luis was talking about, it's very important to have active learning. And we have this year, we have the experience, for example, in this slide, you can see my students working with a 3D printer, and the classes are very different. When you bring something active to the classroom, the students start with a different opinion. And then, we have our laboratories this year are closed due to COVID-19. We needed to find another options. And when we discovered LabsLand, it was very useful for us. Then I will change my sharing to share the sorry. I opening a lot of different things.
So now you want to change to the browser?
Yes, I
I think you need to minimize the PowerPoint. And then exactly.
The browser? Okay.
Now we see the browser.
Okay, excuse me for all these problems. If you, we are going now to focus on LabsLand. This is the page you have when you register. And this is the things Luis was talking about definition, testimonial, and so on. And I'm going to show you inside the page. Here is a very important part because it's not only you have not only labs, but also you can manage the students and you can connect the labs with your learning management system. For example, if you in the home page, you can click on Access My Labs, and then this is my school. And this is the screen you have when you are inside. Then I must to say that it's very easy to add students because you can choose share a link or learning the link in the Google Classroom. In my case, we are using Google Classroom this year in my school, and it was very easy. We only have to give the link and the students access to the labs you want to with them to share. Then we will see the stats, and here you can see when the students are working. Here is the this hour was in the morning with a lesson. We have three lessons a week on Monday, Wednesday, Friday, and here you can see after lessons. For example, I have a student who was working in a lab, 2 students at 11 in the night, or at 10, 3 students working here, 6 students. Then this is one question, that one advantage of this kind of labs. They are open all the day, and the students can practice not only during the lessons but also at home. And then you can see, of course, during the lesson we have 83 accesses, but at evenings we have also inside, also in Sundays we had some students working here. But I'm going to show you, for example, this Arduino board. It's not possible this year to share material with the students, and with solution we could make some practices with Arduino. The one of the best things you can find is here you can find documentation. Documentation is some practices ready to use. This in English, and also in Spanish and Basque, and you can find instructions and so on. And I want to show you because it is very easy to use. In technology, we are using Arduino. And for example, you need this reference. No, oh, sorry. You have this this circuit ready to use with the board with Arduino microcontroller and some switches, LEDs, and servo, a screen, and then it's very easy. You can here make the program. Here is and you verify. It's the same process that you make in a real Arduino lab, but you don't need to prepare the board. Everything is ready, only to make the program. And you can see also in the code vision. And now it's not working because we are on live, and you know, but my computer is. Can you hear me?
Yes, we can hear you, but I think the screen got frozen.
Sorry.
So just for your information, you have 5 minutes left.
Yes. I will try to. Yes, I have my screen frozen also. And my browser is completely frozen.
If your browser is frozen and you cannot share your screen, Danielle, if you want, we can pass it, can pass the floor to Ivan now, and then go back to you
Yes, I have a
while
minute.
you fix it, because I think you have internet problems also.
Yes, maybe I need to go out and enter again.
Yeah,
Yes.
maybe you can go out and get in again. Okay, Ivan, I'm sorry to step in like this, but could you take the floor?
Sure, not a problem.
Thank you very much.
Danielle will.
Yeah, so exactly. We let him some time to fix the connection issues.
Yeah, I think the main problem is that he's still sharing his screen, so I can't share mine until he's done with his.
Danielle, can you stop sharing your screen, please?
Yes, I'm trying to switch off my computer.
Exactly. I think now you can, Ivan.
Let me. I started sharing my screen.
Yes, I can see IMPACT EdTech there.
That's perfect.
Okay,
so
great.
First, greet everyone. It's so nice to see a lot of teachers from Croatia here in this webinar. I was the educational mentor for the LabsLand during these last 5 months of piloting program. And my job is to present pilot results and to talk about next steps of the LabsLand in the future. So in our pilot program, we had 3 teachers with 92 students between them, and they did roughly 20 hours of implementations of LabsLand laboratories in their classroom. That doesn't mean that students did 20 hours. Some of students did more of that. They just did 20 hours of teaching time in their classrooms, not counting the exercises the students did on their own during the after school hours or anything else. Depending on the teacher's field of study, laboratories were different, but they mostly used physics, computer science, and ICT laboratories. LabsLand is a really good platform, and they did really well with their learning scenarios and their implementations. But they also encountered some difficulties and barriers during these implementations of learning scenarios and LabsLand in their classroom. One of the most important things was lack of tech resources. Because LabsLand is an online platform, students need a tablet or a computer or a laptop or anything else to access it. Some schools don't have it for all students, and some students don't have it in their home. So depending on your tech opportunity in the school, you may encounter this problem while accessing the LabsLand. Also, you may notice one problem that Danielle had at the moment. His browser froze. Depending on the processor and the graphic card of your laptop or computer, or even a tablet, you may also encounter these problems. So that is something that could really happen in a real scenario. Some pilot teachers also noted that they encountered some problems with students' behavior. But let me explain that statement. Students were really glad to try some online laboratories, but after 1 or 2 tries, they were okay. This is like it's the same like in our classroom. So they didn't find the enthusiasm to go to the 3rd, 4th, and next exercises. They were like business as usual. So that's something you need to keep a mind on. Using LabsLand doesn't mean that all students will jump on it and be enthusiastic on using it every day and in every scenario. So you need to pinpoint the exact moment when to use it and how to use it. And also few pilot teachers noted that few remote labs fit their curricula of their school. Depending on your curricula, some labs you may find really useful, and some labs you may find that you won't use anytime. So depending on what you teach and how you plan your lessons, you may use something more or something less. We also made a questionnaire for students during this pilot program because we were eager to see what students think of LabsLand. And this is the one question that was really important to us. Most students are neutral on using LabsLand and if they learned more using it. But what we found interesting that 68% of the students agreed that LabsLand is easy to use, and 70% of them liked the practical session and find it more engaging than theoretical sessions during these classroom implementations. So in that being said, most of the students are very well are using LabsLand very well, and they are easy to find their way and to do those exercises in their classroom. I'm a physics teacher, and I didn't get that in my classroom when I was using real physical laboratories. Most of my students were very hard on figuring out what to use and how to use it. But I guess for the students, they don't have that problem in LabsLand. In pilot conclusions, all the pilot teachers said that they would use LabsLand again, and they would also recommend LabsLand to other colleagues. They also think that LabsLand positively impacted on the students' agentic engagement, because they noticed that students were asking questions like how is this working, when we shall use it more, and stuff like that. And they found out that LabsLand had a positive impact on students' emotional engagement. So students were smiling more, they were enthusiastic on doing LabsLand exercises, at least at first. But after using it multiple times in a short period of time, they were like business as usual. They weren't experiencing high emotional engagement after that. This pilot taught us a lot. So in this pilot, LabsLand team created 26 support materials for teachers. In support materials, I think of video lessons and Word documents that explain to teachers how to use LabsLand, and implementations in some learning scenarios and in a real classroom. The most important thing that LabsLand is adding new content on day-to-day basis. We spoke, they had 10 or more learning scenarios and support materials almost ready to go. And the interesting thing is they are always doing something more, like translating it to another languages. So if you don't speak English very well, you can find it in Spanish, for example, for now, and some of them, I think, even in German. Another thing we developed is gathering feedback from teachers. LabsLand is encountering a problem that they don't have a lot of high school teachers using it. They are mostly college-oriented platform. And as we all know, the college students are really different than high school student. So we are gathering a result and feedback from the high school student on the ways to improve LabsLand as a platform, so it's more appealing to the high school students. And in my opinion, they are doing really well, especially after adding support material. And the most important thing for me as a teacher is the pricing model. And they are not sure how to develop their pricing model, so they are constantly getting feedback for the pricing model and changing it on day-to-day basis, because some of us use different labs, so not all groups of labs that are developed for now are used by me. I would like some of labs for physics and some for ICT, but not for chemistry. So they are doing on creating a group of labs that will correspond to every teacher, in short. The most important thing to figure out of this pilot project is that this COVID-19 situation learned us that online classes are future of education, at least for me. And LabsLand, in my opinion, is the future of online STEM classes, because you are not able to do practical sessions with your students every day in your every class, but LabsLand is a way to go for me. And that's it for me and for the pilot results.
Thank you very much, Ivan, for sharing the pilot results with us. So I really like the last quote, future of the STEM online classes. So I'm sure it is the solution developed by Luis and Pablo, if I'm not mistaken. So Danielle, I see you're back with us. I'm going to give you 5 more minutes because we're running out of time and we have the Q&A. So if you want to try again to share your screen, we have 5 minutes.
Yes, I will cross my fingers. I'm sorry. I don't know, maybe with the lab, the video conferences, and my computer.
It's okay.
Perhaps.
I mean, like right now, we need to be ready for this kind of problems in the technology world. So I can see your screen now. I can see the PowerPoint.
Ah, perfect. I will try. Don't touch.
Exactly. Just don't touch it.
Yeah. I have only to say my last conclusion after the time working in LabsLand. And my ideas is we need some lesson plans, but it's very good because when I connect again to LabsLand, I see that every day there is more and more lesson plans ready to use. Then it's been better every week. And also we need more labs for my students, low secondary education, because the electronics labs, for example, are with very high level for my students, but this is a question of time. I think that labs must be not only for these pandemic times. We need to think in the future. In the future, I think that will be very interesting because the remote labs allow repeat experiences a lot of times without spending material or practice, allow homework. The students can continue working and practicing at home. Also, it allows to read the results of the variables in a simple way. In the real labs, sometimes the students doesn't know how to read the results, and here it's very easy because you join the labs with an interface where you can read the conclusion. And also you can see real results. You know, in a simulation, everything is perfect, everything is working based on an algorithm in a program, but in the real lab, the results are real. I think this is very important because the science is not only 100% exact, and also the errors are in a real procedure. And also we can use expensive instrumentals that we don't have usually in the school: oscilloscope, generator of frequency, robots, and the students can experiment without fear because it's not possible to break anything. And then, for some times, it's more useful than a simulation. Simulation is not very good in this time because the students are very used to play with computers. But in a perfect approach, in a perfect classroom, I think we need a combination of simulations to study the laws of science, to work faster, combination of remote labs to see real effects, and of course real labs, presential labs, I think they are very important to feel the science, to get your hands dirty. And I think my time, when I finished, I think we need to combine everything. And I'm sorry because my time is finished.
Thank you very much, Daniel. I mean, normally I will just give you all the time you need, but I see that we're already in 4:40, and we now have some time for a Q&A, so sorry to interrupt you. And I am now going to ask, so Luis, Ivan, Daniel, to turn on your cameras because we're going to have the Q&A session, and I might address some questions to you directly. I think that we also have the other pilot teachers here with us. I think, if I'm not mistaken, it was Patrick is also a pilot teacher. Hi, Patrick. And the third pilot teacher is
Laurentina.
Laurentina.
Okay, I can't hear the name, but Laurentina. I see her there. Okay. Perfect. So I see you all here, so we're ready for the Q&A. So I have already one question from the chat that was asked while we were presenting. And the question, I think it's more directed to Luis. So the question is from a participant in the chat. Can LabsLand be linked to Teams or only Google Classroom?
Not only Google Classroom, we support several learning management systems such as Moodle, Google Classroom, Sakai, Blackboard, and we support authentication through Microsoft accounts, but we do not support Teams integration itself. However, we do support links. So basically, what we do normally with systems that are not directly integrated, it's you can create a link, basically, send the link to your students, and they will arrive at the lab automatically. So it's similar.
Okay, great. Thank you for your answer. I don't know who asked that in the chat, but I think it's enough as yeah, Anita asked that. So Anita, I hope you got the answer from Luis. And now a question for the pilot teachers. So Daniel, Patrick, and also Laurentina, feel free to answer. So if you had to say that there was a before and after using LabsLand and piloting in your school, do you think there was a before and after, and did it change the way you teach your students? You're muted, Daniel, sorry.
In my case, I think it was very useful because I was studying how I was using the labs. For me, it was very important to study myself how the students were answering the behavior and so on. And then I learned a lot.
So you even learned yourself with LabsLand. That's great.
Yes.
Not only the students, but also you. Yeah, Patrick?
Yeah, so also thank you for this opportunity, obviously. But as a pilot teacher, I look at it a bit different from Daniel in the sense that for me, LabsLand is just a means to an end. And the means is that the students will learn the skills and understand, or in a better way, understand the theory, whatever you're teaching. And what Ivan already said, there's like some labs that were brilliant, and I must say the Arduino is absolutely amazing, and it really addressed the needs, because Ivan also mentioned equipment and some being expensive, etc., etc., etc. And the Arduino labs, multiple, they were amazing in that they provided the means to an end, as in we already teach them how to, well, we use Scratch, but it's a visual block programming environment. But it was all just very, virtual. And the idea or the experience that they could actually now see their robot running or driving and going the wrong way or the right way or anything in between, it was like really amazing for the students. So LabsLand, to that extent, did not change the practices, because I would, I would focus on the some learning objectives anyway, and LabsLand was just there to address that need. and LabsLand fill that learning need brilliantly. Having said that, there were also opportunities where I wanted to, where the learning objective was, like, for example, manipulating equipment. I think that LabsLand was not so suitable for that. On the other hand, positioning LabsLand in an inquiry learning approach, it was very suitable, and many labs were very, very useful for that. So yeah, all in all, hasn't changed how I approached how I would approach the lessons. I would do the same anyway. I have an inquiry learning approach, and I don't change my learning goals. But in some cases, LabsLand was really like the tool I needed to,
The bridge, no?
Yeah.
Like to get to the other part.
Yeah.
Great. Thank you very much for that, Patrick. So it didn't change the way, but it was there, Luis, as the bridge to cross and be able to reach the students. So that's great. And I'm going to give the floor to Laurentina, who I think raised her hand before. But I don't know if she's still with us. Laurentina, are you still with us? Maybe not. It's okay. So we reached the end of the webinar.
Yes,
but
I am here, but my internet, it's very bad. But I agree with Neil and
I guess that she wants to say that she agrees with all of you. But I'm not sure.
I work in FL. Yes, of course. Sorry, my internet is very, very bad. And I work with my students always online. We come back to school only this week. But I pretend to use the LabsLand in later works, of course, and my students like a lot.
Thank you very much, Laurentina. I'm so sorry that you have that connection, but I guess what she said, if not everyone could understand it, is that so far she has. Okay. We can't hear you properly. I'm sorry if I'm speaking over you. But what Laurentina tried to explain is that I think that what she tried to say is that so far she has taught online and she taught online. She's only back to on-site classes now, but she will continue using LabsLand. So I think that's good news. And well, we reached the end of the webinar. Thank you. I would like to thank Luis, Ivan, Patrick, Daniel, and Laurentina for being here today and for presenting the results of this piloting phase. And to the startup, to LabsLand, Luis, so the best of luck after the IMPACT EdTech program. I'm sure you're going to get more feedback on piloting from more schools now that you invited everyone to join you. And the best of luck to all of you and also to the teachers in using LabsLand or other solutions in your school. And thank you very much to the attendees that were here today on this session. And thank you to the team, Roman and Sofia, that have been behind the scenes. So despite all the technology and connection issues, I think we reached the end. So thank you very much, and maybe see you in the last webinar or see you soon.